Hi everyone, this is Dr. Samsung. Today we're going to look at NCEA Scholarship 2016 Calculus paper. This is question 1B. We've covered question 1A in the previous video, so today we're looking at B. Okay. Now, for real numbers x bigger than minus 1, function x squared line x plus 1. Find the second derivative of function x. Then find the value of this derivative at x equals 0. Then find the value of the 2016 derivative of function x at x equals 0. Write your answer in factorial form. So, reading the question, we know that we need to find this 2016 derivative in the second one, which means there must be a pattern because it's going to take thousands of hours to get the 2016 derivative. So, we're looking for a pattern. Now we're going to do the first question. Okay. So, this is function equals to x squared line x plus 1. So, in order to get the second derivative, we need to get the first derivative. Right. Okay. There are two functions in this function, x squared and line x plus 1. So, we need to use the product rule. F g dash plus g f dash. So, f is x squared, g is line x plus 1, f dash is 2x, and g dash is x plus 1. No, 1 over x plus 1. Okay? Because the derivative of x plus 1 is 1, so we just ignore the 1. Okay. Now, that will be f g dash plus g. Sorry, it should be g f dash. My bad. So, it's going to be 2x plus... sorry, that was a mistake. F is x squared. G dash is 1 over 1 plus x plus line x plus 1 times f dash, which is 2x, sorry. So this will look something like so. Now we got this first derivative. I want to make this look simplified. What should I do? So here's a trick. There's this formula, which I think will be useful, is a plus b times a minus b equals to a squared minus b squared. So, if we're just going to add a plus 1 here, you can see we have this pattern, a plus b, x plus 1, a minus b. We have x squared plus 1, so that will be, that'll be x squared minus 1. And so, x will be the a and b will be the 1. But we minus a 1, so we need to plus a 1 back. So, if I cancel these out, those are still going to be 0, so it's okay. Alright, so we're going to split this function. Okay, so this will be x plus 1, x minus 1, plus Okay, so now we have got this plus x minus 1 plus 1 plus x minus 1. So that is our first derivative. And now we're going to look at the second derivative. Same thing. Product rule for the first, no, sorry, just the first one, not the second one. Okay. So this will be 2x times x plus 1, that, and plus 2, line x plus 1. Okay. I'm just going to rub these to give me more space. Okay. And then we differentiate x. X is 1. Minus 1 is 0, so we don't differentiate that. We ignore it. Then we can differentiate this thing. Okay. Chain rule. Can you see a pattern here? That if I keep differentiating this will drop down and this will become minus 3 and it will keep on. Do you get this? Okay. Very good. So, but to get this pattern, I want everything to be a constant coefficient instead of a variable. So, what I'm going to do here is, this is 2x over x plus 1. If I back this into 2x plus 2 minus 2, and so this will equal to 2x plus 2 over x plus 1 minus 2, that. You can see this will become 2, and this will become 2. Okay? Okay. So, this is so, because if we take out a number like this, which means we're going to have a constant coefficient at the front of this function, which is easier to do. Okay, next we have 2 plus 2 line x plus 1 plus okay. Oh, sorry, I missed the plus 1 here. So that'll be 2 line x plus 1 minus 2 x plus 1 minus 1 plus minus 1 times that, then plus 3. Okay. So this is our second derivative, and remember the question, we need to find the value of this derivative at x equals 0. So when x equals to 0, what is this going to be? Equals to 2 line 1 minus 2, 1 that, plus minus 1, 1 plus 3. Line 1 is log e1, or equal to 0, because e to the power of 0 is 1. That's the log rules. If you don't know about this, you should go and take some revision. Okay, this is 0. This will be minus 2 over 1, because 1 to the power of minus 1 is 1 over 1 minus 2, plus, oh, sorry, minus, because 1 to the power of minus 2 is 1 over 1 squared equals to 1, times minus 1 is also minus 1, plus 3. So this is going to equal to 0. And now We have done this question. Now, we're going to find the value of the 2016th derivative of fx at x equals 0. Remember, we can see a very clear pattern here. Okay? Because if we differentiate this one more time, this constant is going to disappear. Okay, now let's differentiate this again and see if this is a good pattern. So, differentiate. Product rule. Okay, this will be what? Oh, this is not product rule, sorry. This is a constant, this is not a function. This will just be 2 times 1 over 1 plus x minus 2 times minus 1 x plus 1 minus 2. Then this is a chain rule. Yes, this is a chain rule. Then plus minus 1 times minus 2, 1 plus x minus 3. And this plus 3 here, ignored. It's not useful. Okay. Now, we have this pattern. Can you see? If I keep differentiating this is going to be something like 2 minus 1, x plus 1, then minus 2, minus 2. Can you see this? Yes, so this is a very good pattern. Okay. So now, we are finding the value of the 2016th derivative of fx at x equals to 0. So let's have a look. So this is the third derivative, and the last term of this expression, the power is minus 3. Okay, so if it's the f 2016th derivative, it's going to be, wait, hold on. See, this is minus 3, but here is minus 2. So which means the last term of this will be so it's only the last term, last 3 terms of the derivative, because we only have these 3 terms. So these will keep getting differentiated. So the last term power is going to be minus 2016 and minus 2015 and minus 2014. Okay? And you see we have this pattern over here. This is 2. This is going to keep timesing by, remember, this is minus 3 and this is minus 2. So this is going to times till minus 2013. Okay? And this will be minus 2, minus 1, till, sorry. Alright, this is a function here, sorry. Alright, I messed up. Okay, times minus 2014, then x plus 1 to the power of minus 15. Then this is, so this is a plus here, so this is going to be minus 1, minus 2, minus 15, then 1 plus x 2016. Oh, what? Okay. Rub this off. Oh, sorry. Okay. When x equals 0, this is going to be 1, 1, 1. Does that make sense? Okay. So now we've got this pattern is 2 minus 1, blah, 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 times minus 2013 times 1 minus 2 minus 1 times 2014. Sorry, minus 2014 plus times 1 plus minus 1 times 1. And remember, when they are even numbers, even number of negative numbers multiplying together, the whole thing will be positive. If they're odd numbers of negative numbers, they'll be negative. So this 1 to 2013, that's obviously an odd number. So this will be, so factorial is when so 5 factorial equals to 5 times 4 times 3 times 1. So which means 1 times blah 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 times 2013 is the 2013 factorial, but because it's a minus, so this will be times factorial. Then this even number minus 2 factorial. Then minus, see this? It's a 2015 factorial. Okay, so this is minus 2 times 2013 minus 2 times 2014 minus 2015. Okay, so we want to simplify this. How can we do that? So take a common factor out, you know, because this factorial of 2014 is 20, then to 1. This is 2013 to 1. This is 2015 to 1. So 2014 factorial equals to 2013 factorial times 2014. Okay. Now, this is going to be minus 2. No, sorry, that's a plus 2. Times 2, okay, common factor. Then this, so times 2014, okay. Then times the common factor minus 2013, and this will give us 2014 times 2015, okay. What's this equal to? 2 times 1 plus 2 times 2014, which means that will be 2 times 2015, because I can just take this, right? Okay, just going to simplify that. Times 2015. Okay, this is what? 2016 times 2015. Is that clear? Common factor of 2015 plus these, so that's 2016. So now The factorial of 2016 is 2016 times 2015 times 2014 times blah blah blah, right? You see? In order to have a 2016 factorial, we'll need a one more 2014 in this case, right? Because this factorial covers the one after 2015, and we have 2016, 2015 here, so we need 2014 here, which means the answer can just be, actually, no, I'm going to do times 2014 times 2015 times 2016, then divide by 2014 because we times something but it doesn't exist, so we have to divide it. So this thing will be a minus 2016 factorial. Is that clear? So divided by 2014. So now the final answer is this. Okay, thank you. I am Dr. Samsung. Please follow me for more videos. Thank you.